Now on to the cycloalkanes or the ring masters, okay? They're going to be under the guidance of the cyclohexane chairman. And they're always going to specialize in forming closed rings, right? And networks of rings as well. So a lot of the functions of our really cycloalkanes and wells are going to be like they could be solvents. They're part of the building blocks of biomolecules. They can be a part of antiviral drugs, anesthetics, things like that. The goal is that when you have a cycloalkane, is you always have a cyclical alkane with one or more rings in its structure. And normally you would just have single bonds, as you can see here. You can have one ring or you can have more than one ring, okay? Now, when it comes to naming cycloalkanes, guess what? You're going to name them just like the alkanes, but got to have some changes. And guess what that change is going to be? You have to include a prefix in the root. And that prefix is going to be cyclo. So let's say we have this one here. It's going to be 1, 2, 3, 4, 5, 6 carbons. So that's going to be hexane. Well, because it's cyclical, it'll be cyclohexane. So the root, you have to add a prefix to it. Also, the actual ring structure needs to be the longest carbon chain. So if you have a ring like this, which is only 1, 2, 3 carbons, as you can see, the longest carbon chain is going to be 10 carbons here. So this actually will act as a substituent. So just like we've seen everywhere else, when you have like a 1 carbon substituent, it's called methyl. You're ending with that YL. Well, guess what? When we have like a 3 carbon ring here, that means we're going to have cyclopropane. And if I make this a substituent, it'll be cyclopropyl, right? So it's always going to end with that YL. Okay, folks? Again, let's get into some examples of how to name cyclohexane. I keep on saying cyclohexanes because I'm like looking at this example, but I want to say cycloalkanes in general. Okay, so like everything else, you have a prefix, you have a root, and you have a suffix. And we know when we're dealing with cycloalkanes, the cyclo has to be a part of the root first. So you have to be cyclohept, cyclohex, cyclopent, etc., etc. The cyclo has to be added to that root. Okay, so that's the main thing that's going to really change. Everything else, the rules are the same. So let's go ahead and get it. We want to make sure that our cyclo or the cyclical part is the longest carbon chain. So as you can see, we have 1, 2, 3, 4, 5, 6. That's going to be 6 carbon. This is only 2 carbon attached to this. This is only 1 carbon attached to that as well. So the next thing you want to tell yourself is like, okay, I know I have my 6 carbons. Now I need to basically add my root. Because this is going to be cyclical, I have to have my cyclo, hex, all single bonds, ane. Okay, so cyclohexane, I got my root and I got my suffix. The prefix is what we got to work. Okay, so the prefix is going to be everything that is outside of the parent chain. So this is the substituent methyl here, 1 carbon. There's 2 carbons here, so that's going to be ethyl. Now, when it comes to naming, we know that ethyl is going to be in alphabetical order. So that one is going to come first. And guess what? When it comes to trying to number the ring, that's another way that you can figure out how to number things. So some people are like, well, how do I number it? The way you number it is you first look at the substituent, you figure out what it is. Of course, halogens are going to be more, they're going to be more favored over like other substituents like these alkyl groups. But when you only have alkyl groups that you see here, you go by alphabetical order. So the ethyl group is here. That means I want to have the lowest carbon number on that substituent. So it'll be 1. Okay. And then, of course, you want to have the lowest number on all the other substituents. So if I was to go 1, 2, 3, 4, 5 here, it'll be a 1, 5 ethyl methyl. But I want to make sure I have the lowest numbers. So I'll have 1, 2, 3, 4, 5, and 6. So I have on carbon number 1, I have an ethyl group, and on carbon number 3, I have a methyl group. So I just would put this all in alphabetical order. 1-ethyl, -3-methyl, cyclohexane. There we go. Now let's go ahead and get to this one. Again, we want to make sure we have that root, and we want to make sure that the cyclical part is the part of the longest carbon chain. 1, 2, 3, 4, 5. Okay, we only have 2 carbons here, and we have 1 carbon here. So that means we do have a 5 carbon cyclical part. So 5 carbon is going to be pent. So we need to make sure we have cyclo. It's all single bonds, so cyclopentane. As you can see, our root has changed slightly because we changed the prefix. Now we got to focus on the substituents. So we have a carbon here, 1 carbon, which is a methyl group. And then we have a 2 carbon substituent here, which is going to be an ethyl group. How do we number them? We want to have the smallest number. So we can start here at carbon number 1, 2, 3, 4, and 5. So at carbon number 1, I have an ethyl group. At carbon number 2, I have a methyl group. So the name of this will be 1-ethyl, okay, 2-methyl cyclopentane. And I do want to add, just like with the haloalkanes, the cycloalkanes means that you can also have double bonds and single bonds, but we're not going to be focused on that for our course. We're only going to be focused on things that you will see in the examples in the lecture. Okay, folks?